So, algebra. What are the basic rules of algebra? Well, algebra is just when you've got a combination of letters and numbers. Let's say, for example, we have the expression x plus 2 equals 9. Well, we know that 7 plus 2 must equal 9, so we can actually say that x must equal 7. When you were younger, you used to just cover your finger over the x and say, what plus 2 equals 9, and you worked it out as 7. Then when we were in 8th grade, we showed you a little bit about what you could do to both sides of the equation to get the letters on one side and all the numbers on the other. Well, we talked about taking away 2 from the left-hand side of the equation here to get rid of the positive 2 here. 2 minus 2 would give you 0 here. And if we take away 2 from the left-hand side of the equation, we have to do exactly the same thing to the other side of the equation. So we would take away 2 here. So in algebra, as long as you do exactly the same thing to both sides of the equal sign, you can pretty much do what you want. This would give us that x plus 0 would equal 7. Otherwise, x equals 7, which is what we would expect when we had use the finger method as well. Now when you get into 9th grade, you can actually look at this expression, x plus 2 is equal to 9, and think, okay, I want to get x by itself. I'm going to move the 2 to the other side. When I move the 2 to the other side, I change sign of the 2. So x equals 9, and because it was plus 2 on this side of the equal sign, it's actually going to end up being minus 2 on the other side. So we get the expression x equals 7. And this is a pretty important concept in algebra, and it helps you a lot if you know these techniques. So, if x divided by 7 equals 1, and I'm using this technique where I want to get all my x's on one side of the equation and all my numbers on the other, in 9th grade, we can say that I want to take this divided by 7 and move it to the other side of the equal sign, which will give it multiplied by 7. So x is going to equal 7. And that's pretty sensible, and you can always go back and check that you haven't made a silly mistake. If x equals 7, then substitute it back into your original equation. X divided by 7 equals 1, but I know now that x is supposed to equal 7. Does 7 divided by 7 equal 1? Yes, then I've done it correctly. What do we do then when we have a combination of letters plus numbers? X divided by 6 minus 4 equals 2x plus 10. Well, the easiest thing to do here is x is on one side and numbers on the other. I would look at this equation and say, right, the most sensible thing for me to do is actually to move the x divided by 6 over here, because here is positive x, and I'm much happier working in positive x's, the largest possible version of possible x, than the other way around. So what I would get then is minus 4. I will move the plus 10 to the other side of the equation, giving me minus 10 here, equals 2x. When I move the x over 6 to the other side of the equation, I get minus x over 6. So what I get then is minus 14 equals 2x minus a sixth. If I take x out of the front here and put a brackets in here, I have 1 minus 1/6, all multiplied by x. Both of these expressions here are multiplied by x, so I can take the x out of the front. Sorry, not a 1, it was 2x, so it's 2 minus 1/6. So what do I get then? Well, if we just look at 2 minus 1/6, 2 is the same as 12/6 minus 1/6, giving me 11/6. So I know that minus 14 equals x times 11/6. Now what I can do to simplify this expression further is I want x by itself and I want all the numbers on the other. Well, because I was dividing 6 here, I will then get that I multiply by 6 on the other side, so minus 14 times 6. And because I was multiplying by 11 up here, when it moves to the other side, I will divide by 11. So I will get that x is minus 14 times 6 divided by 11. Not really great numbers here, but once we have that value for x that we can calculate here, we can then just punch it back into the equation and check that it worked. Right, let's have a quick look then. Well, 14 times 5 would be 70, so 14 times 6 would be 84 divided by 11 minus. So x equals minus 84 divided by 11. So I wasn't very kind to you here. The numbers aren't really very nice, but it doesn't matter. Let's prove that x does equal minus 84 elevenths. Right, what do we do now then to make sure that we are correct? And we want to check that x equals minus 84 elevenths. We actually substitute, instead, where every time we see x, we actually put in our solution here. We think that x equals minus 84 elevenths into the equation up here. So I've prepared the next